this. And this also looks familiar. This also looks like this. Okay. And all of these terms are over h. Okay? So what we can actually do now is this is, and let's keep in mind that the limit of a plus b is the same as the limit of a plus the limit of b. Let's keep that in mind. So therefore we have, let me just bring this back down here. So therefore we have f prime of x must be equal to, so it's this particular product, here, but where we have a summation here, well, a difference. So once again, keep in mind that the limit of a minus b, as let's say under some sort of, let's say as h tends to 0, is the same as the limit of a as h tends to 0 minus the limit of b as h tends to 0. So we can break this up into two limits. The first limit is the limit of v of x times u of x plus h minus u of x, okay, as h tends to 0 all over h, minus the limit of this bit, the limit as h tends to 0 of u of x times v of x plus h minus v of x, okay, all over h times 1 over v of x squared. And once again, here we have a function times another function. Okay, so what we can actually do is we can actually take this out. We can actually differentiate this out like what we did earlier on up here. So we can differentiate this function with respect to x. Sorry, not differentiate. We can calculate the limit of this particular function as h tends to 0. So what this actually, and you can see that as h tends to 0 on this function here, we just have, well, like up here, as h tends to 0 on v of x, it just goes to v of x. So this now becomes this now. Let me just move this up here. So therefore we have that f prime of x must be equal to, this just becomes v of x times the limit of u of x plus h minus u of x all over h as h tends to 0. That's what this piece becomes. Minus, once again, we take the limit of u of x as h tends to 0 is just u of x. So minus u of x times the limit as h tends to 0 of, whoops, let's move up there, of v of x plus h minus v of x all over h. And this all needs to be multiplied by, this particular term here, 1 over v of x squared. And we're just about there now, okay? Because this is the definition of a derivative, yeah, okay? This here is a derivative of u of x, because we know, once again, is that the derivative of a function, okay, that g prime of x is simply equal to the limit as h tends to 0 of the function plus h minus the function all over h, as this is our definition of a limit. And this is exactly what we have here. You can actually see that this is here, but that we have a change of function name. Instead of a g, it's a u. And similarly over here, the function that corresponds to this part of the limit is the function v. So actually this now becomes, therefore we have f prime of x is equal to v of x times, well, this is the derivative of u of x, okay? Minus over here, this is u of x times, well, this is the derivative of v of x, okay? And this all needs to be multiplied by 1 over v of x squared. So this actually is all over v of x to be squared, which is exactly what we had earlier. Okay, if I rewrite that, okay, so this is our proof done. It's what we wanted to show, and just to write it in the way that we had it earlier on. Okay, well, this is the derivative of u. So this is a times b is the same as b times a. These commute. So this is the same as the derivative of f of x. Therefore, we have the derivative of f of x is equal to the derivative of u with respect to x. That's what this piece is here. Oops, let's just cross it off. Times v, the function v, minus, this is, we just got rid of v here, minus u of x, which is just, in short notation, is just a function u, times the derivative of v, which is dv dx, which needs to be divided by, well, the function v of x to be squared, which is just v squared, which is exactly what we've been familiar with when we've been dealing our our quotient rule, with our quotient rule. Okay, guys. Once again, this was Jonathan Lambert with the. This is Jonathan Lambert with Maths and Stats, and in this particular video, we were concentrating on a derivation of the quotient rule from first principles. And I hope that this particular video was intuitive, and more importantly, I hope that was helpful to you. And thanks for watching. Okay, bye bye.